All right, we're going to prove that for all n greater than or equal to 1/2 plus 2 over 2 squared plus 3 over 2 cubed plus dot 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 plus n over 2 to the n is equal to this formula. So proof by PMI. So we have our base step. Consider P of 1. So that's 1/2. And then that's 2 minus 1 plus 2 over 2 to the 1, which is 2 minus 3/2, which of course is 1/2. So that checks out. Let's consider P of 2. So that's 1/2 plus 2 over 2 squared. That's equal to 1/2 plus 2 over 4, which is 1/2 plus 1/2, which is 1. And then we have 2 minus 2 plus 2 over 2 squared, which is 2 minus, so that's 4 over 4, which is 2 minus 1, which is equal to 1. So that also checks. So let's go ahead and move on to our induction step. Suppose P of k is true. Thus, we have 1/2 plus 2 over 2 squared plus 3 over 2 cubed plus dot 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 plus k over 2 to the k is equal to 2 minus k plus 2 over, and then it was 2 to the k. All right, so let's go ahead and consider 1/2 plus 2 over 2 squared plus 3 over 2 cubed plus dot 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 plus k over 2 to the k plus k plus 1 over 2 to the k plus 1. We know this sum is equal to, by our inductive step, right, 2 minus k plus 2 over 2 to the k, and then plus k plus 1 over 2 to the k plus 1. All right, so we need to find a common denominator here. So that's going to be 2 minus. So if I multiply top and bottom by 2, that's 2 times k plus 2 over 2 times 2 to the k plus k plus 1 over 2 to the k plus 1. And the reason why I did that is because, of course, 2 times 2 to the k is the same thing as 2 to the k plus 1. So that's 2. And yeah, minus 2k plus 4 over 2 to the k plus 1 plus k plus 1 over 2 to the k plus 1. Now I'm going to distribute that negative here. So that's 2 plus negative 2k minus 4 over 2 to the k plus 1 plus k plus 1 over 2 to the k plus 1. And then this is 2 plus, and then here, minus 3 over 2 to the k plus 1. And I can rewrite this as 2 minus k plus 3 over 2 to the k plus 1, or 2 minus k plus 1 plus 2 over 2 to the k plus 1, which is what I wanted, right? I wanted to show that the sum up to the k plus 1 terms is equal to the formula if I plug in k plus 1. Thus, 1 over 2 plus 2 over 2 squared plus 3 over 2 cubed plus dot 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 plus k over 2 to the k plus k plus 1 over 2 to the k plus 1 is equal to 2 minus k plus 1 plus 2 over 2 to the k plus 1. So this works for the k plus 1th term, right? Therefore, by the principle of mathematical induction, for every n contained in the natural numbers, we know 1 over 2 plus 2 over 2 squared plus 3 over 2 cubed plus dot 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 plus n over 2 to the n is equal to 2 minus n plus 2 over 2 to the n. And that is our proof.